that solution would be correct actually. Because you want to find the difference between the amount of kilowatt hours he's consumed at the end of the month and the reading that the meter would have at the beginning. So once you find the difference between those two, you would find the kilowatt hours he consumed, well, the kilowatt hours of electricity that he consumed between those two points in time, right? And seeing as how he's charged at $5 per kilowatt hour, you would multiply that difference by $5.10.
Okay, sir. Thanks.
Yeah. If you plug that into your calculator, as I'm doing just now, you would get $1,509.06. Is that what everyone got?
Oh.
Hello? Did anyone get that?
What question are you talking about?
B1. BI, sorry.
C1, yeah, C1. BI. Did everyone catch that?
Yeah.
All right, great. All right, so moving on to part 2. For the next month of April, April 2016, John pays $2,351.10 for electricity consumption. Determine his meter reading at the end of April 2016. Okay.
I think I know how to do that one.
Similar, but you'd have to do a bit of transposition in this case.
You have to see the table, you know.
Oh, okay, my bad.
Is the answer 3,768?
Yeah, that's correct. And what did you do?
All right, well, I know to get the total, they had to multiply it by $5.10. So I divided by $5.10 and I add the answer to the last reading to get this.
Okay, all right, great. That is correct. Yeah, great. Do you guys want me to write it, or did everyone catch that? And does everyone understand?
I got it.
Everyone understand? All right, great. So as he said, the answer is 3,768. So all he did was just do a bit of transposition, right? And he transposed for the amount of electricity that you'd pay at the end of April. Seeing as though, well, if we're following the solution from part 1, all he did was just divide the 2,351 by 5.10, right? And then he added 3,000, which would be the kilowatt hours at the end of March, to that answer, right? And that's how he got the solution being 3,768. All right, great. Moving on to the next question. Okay, so this is question 2, part A. factorize the following expressions completely. So you guys cannot attempt it, all right? And then tell me the answer you guys get.
Okay. It's the second.
Hello?
I think I got it. Is it 3y subtract 6x? 3 times
Wait, that again?
3 is outside the bracket, and in the bracket is y subtract 6x.
All right, so that's close, but
I got
that's,
y
mm-hmm.
open bracket 6y minus 3x close bracket.
All right, once again, that's close as well. But remember, when you're factorizing expressions completely, there can't be any common factors in the solution, right?
Oh,
So,
I'll check.
So the common factor.
Remember, in this scenario, we're using something called the HCF, highest common factor, of all the terms in the expression.
I got 6y open bracket y minus 3x close bracket.
Yeah, that's correct.
Is that correct?
Yes,
yeah, that's correct.
That's what I meant. Sorry, that's what I meant. I had that, but I said another thing.
All right. So let me just type up something real quick. Okay, so when it says to factorize, you have to factorize out the highest common factors, right? In both the terms. The highest common factor in both terms would be 6y, right? Because you can get 6y in both the terms, right? So the solution would look something like 6y, y minus 3x. If you multiply the 6y through this, you'll get back this exact expression. You'll get back this exact expression, right? Did everyone catch that?
Yeah.
All right, great. All right, so the second one now, let me just scroll down to that. Erase this first. Do I have to erase it? Yeah. All right, great. So scrolling down, part 2. So you guys attempt that and then tell me what you get.
I got 2m minus 1. I got that is in the bracket and I put that in the square.
Okay.
I got
okay,
2.
So
Okay.
I got.
Okay.
I got
2. Okay.
I got 1m in brackets 4m subtract 1.
Answer, sir. I got first bracket open bracket 2m minus 1 close bracket. Then in another bracket, I have open bracket 2m minus 1. Is that correct?
Okay, so the last one was the closest one to the answer.
So I think I have it. 2m minus 1 in one bracket and then 2m plus 1 in another bracket.
Yeah, that's correct.
Oh, yes, that's right.
The difference to two squares, you have to change or alternate the signs.
Yeah, so this expression is what you or what persons call a difference between two squares, right? So if you, let me type something real quick. All right, so if you express this can be expressed as 2m. Where can I find the?
Alright, so we'll say alright, so 2 t squared minus 3t minus 2 to the product and so I don't know which one. 2 so I'm gonna equal to 3, but that negative 3, yes, negative 3. So 2 times that equal 4, what give 4? So 1 times by negative 4, yes. Alright.
Right. So yeah, this expression is what you would refer to as the difference between two squares, right? And when you factorize a binomial, that is an expression containing two different terms, that is can be considered a difference in two squares. You would factorize it as, hold on, 2m plus 1, in this case, multiplied by 2m minus 1. All right, this is just a general rule. When you multiply these, hold on. When you multiply these two, you get back this exact expression, right? So that's just a rule of thumb, right? So anytime you see an expression like a binomial that has two different terms and you're asked to factorize it, first thing first, check to see if it's if the two terms are perfect squares, right? Perfect squares meaning that when you multiply them or when you divide them by themselves, you get the exact same number, right? Example 4, 36, 9. Yeah, those are all perfect squares because you multiply two factors that are the same to get them, right? So when you find the square root of each term, if you get what you call it, a whole number or yeah, whole number. Yeah, if you get a whole number, that means a perfect square. And once you get that, the general rule is that, let me type it here. If you have a squared, oops, a squared minus b squared, right? It can be factorized as a plus b times a minus b, right? So as you can see here, the a would be 4m squared and the b would be 1. So you can memorize that as a rule of thumb. All right, so next, did everyone catch that?
Yes.
All right, so moving on to third one. I'll let you guys attempt that and then tell me what you get.
So I got, in the first bracket, I got 2 minus 2, and in the second bracket, I got 2t plus 1.
Say it again.
In the first bracket, I got t minus 2, and in the second bracket, I got 2t plus 1.
Yeah, that's correct. That's correct. Well done. That is correct. And everyone get that?
Yeah.
All great. Do you need further explanation, or does everyone understand how to do that?
Jada?
Explain for me, please.
All right. So, yeah. Hello? Someone say something?
What is it, Jada?
All right. So I'm gonna go through the solution for this one. Let me find the text. Yeah. Okay. So for this, you have 2t squared minus 3t minus 2, right? Usually when you're factorizing trinomials, well, a quadratic equation like this, there are rules that you have to follow, right? So the rule that we're gonna follow in this case is the one where you find the expression by grouping, right? So you're gonna have 2t squared minus 3t minus 2, right? So let me type out something. Where we have example ax plus bx plus c, right? Or ax squared rather, my bad, ax squared. Minus bx minus c, right? Or plus, it doesn't matter, I'll just put plus for generalization's sake. All right, so this is called a quadratic expression because the highest term is raised to the power of 2, right? And then the terms decrease until it comes to a constant. And the constant in this case is 2, right? Great. So when you're factorizing by grouping, right, you would find the product of the first term and the last term, right? And in this case, it would be 4. And that would be AC. So instruction, find AC, right? Once you find AC, you have to find what would give you a product of AC and a sum of B, right?